For my Pencast, I did problem number 5. This is the Diamondback problem. The Diamondback at Kings Island is 49.4 meters. There is an 83-degree angle. The mass of the cars is 1,700 kilograms. And there's a friction of 0.29. And velocity is 0 at the top, right before it falls. Part A is asking the magnitude of the frictional force. That is the friction times the normal times cosine of the angle. So 0.29 times 1700 times 9.8 times the cosine of 83. That is 590 newtons. Part B is how much work is done on the cars by friction as it goes down. Answer in 2 significant figures. I use this equation: work equals force times distance, a cosine of theta. So the force is the friction times mg, distance cosine of theta. Now I just plug everything in. Work equals 0.29 times 1700 times 9.8 times 49.4 times cosine of 83, and work equals 29,086. I want it in 2 significant figures, so it's this should be negative actually because of the gravity. So it's 2.9 times 10 to the 4 joules. Part C is asking how fast the cars are moving at the bottom of the hill. First, define the energy through the whole system, which is mgh, 1700 9.8 times 9.8 times 49.4, and that is 8,238 43.8. Now that I know the energy, I can find the velocity for E2. And since E1 equals E2, I can simply put that equals E2, which is just the 1/2 mv squared, the kinetic energy. So 1/2 1700, divide that, and v squared v, and then you take the square root, and v is equals 31 meters per second. And those are your answers.